No human has ever seen a great white shark give birth in the wild. Not once, ever. Everything scientists know about it comes from indirect evidence, dead pregnant females examined after accidental capture, genetic testing on newborn pups that washed ashore. That's the entire foundation of what we think we know. So researchers tried something different, actually following a pregnant female shark in real time for weeks as she approached the place she was likely going to give birth. This is that tracking data. 30 days, one shark, and the closest science has ever come to solving one of the ocean's oldest mysteries. Welcome back to the Abyss Report. The shark in this story is a mature female great white shark, large enough based on established growth data that researchers estimated she was very likely pregnant. Estimating pregnancy from size alone isn't perfect, but for large, mature females, it's one of the only field indicators available. She was fitted with a satellite tag, clamped directly to the base of her dorsal fin. This kind of tag doesn't need to be retrieved. It transmits data automatically. Every time that fin breaks the surface, even briefly, the tag sends a location ping to a satellite passing overhead. It doesn't track her constantly. It only transmits the moment she surfaces, sometimes minutes apart, sometimes hours. Over the following 30 days, those individual pings built a continuous moving trail across the map. Each ping recorded a precise timestamp, coordinates, and, depending on the tag model, depth and water temperature. Together, it became a rare, direct window into where a pregnant apex predator actually goes, in her own words, one surface breath at a time. Modern shark tags rely on a satellite system originally built for tracking ocean buoys and weather balloons. Each tag has a small antenna and battery designed to survive years of saltwater exposure and repeated pressure changes. Some tags also store data internally, recording thousands of depth readings between transmissions. That stored data is only recovered if the tag eventually detaches and washes ashore, or if the animal is recaptured. Real-time pings, by contrast, upload instantly, letting researchers, and often the public, watch an animal's movements almost as they happen. This shift, from data recovered years later to data visible within hours, fundamentally changed what scientists can study about pregnant sharks specifically. For an event as rare and unpredictable as a wild birth, near real-time tracking is the only realistic way to even attempt to be close. It still isn't a live camera. It's closer to reading a very slow, very sparse text message sent from an animal that has no idea it's being read. Day 1. The tag begins transmitting from open water, far from any coastline. Over the following days, her pings show a clear, consistent direction, north along the edge of the continental shelf. She stays in deeper water rather than following the coastline directly, a pattern researchers describe as a directed migration. Not random wandering, but movement that looks like it has an actual destination in mind. Female great whites are known to travel thousands of miles during pregnancy, crossing entire ocean basins between feeding grounds and suspected nursery areas. Some tagged individuals in other studies have covered distances comparable to swimming across an entire ocean and partway back. By day 7 of this tracking period, she had already covered several hundred miles. The tag also records depth and temperature data with every single ping it sends. During week 2, her dive pattern begins to change in a noticeable, consistent way. She spends more time in shallower, warmer water during daylight hours, then drops into deeper, colder water at night. Researchers believe this behavior may help regulate her own body temperature, or possibly that of her developing pups. It's a process that isn't fully understood in any shark species studied so far. Her overall pace also slows noticeably during this stretch of the journey. Where she once covered nearly 50 miles a day, she's now covering closer to 20, as if she's getting closer to somewhere specific. Here's what makes this tracking data genuinely significant. Great white shark gestation is believed to last around 18 months, one of the longest of any shark species. Though even that widely cited number is really just a careful estimate, not a confirmed measurement. Great whites don't lay eggs. The pups develop fully inside the mother's body, nourished partly by a steady supply of unfertilized eggs she continues producing throughout the entire pregnancy. Litters are usually small for an animal this size, sometimes fewer than 10 pups total. And because no human has ever documented a wild birth, scientists genuinely don't know the exact how or the exact where it happens. We only know that it does happen because newborn pups eventually turn up alive somewhere along the coast.
If she did give birth in that nursery area, here's what the science suggests likely happened next. A newborn great white pup is already close to 5 feet long at birth, fully capable of swimming and hunting almost immediately. There's no parental care in this species. The mother doesn't stay, doesn't guard, doesn't feed her pups. In fact, researchers believe adult great whites may actively avoid shallow nursery habitat, partly to reduce the risk of preying on their own species' young. From the moment of birth, each pup is entirely on its own, in open water, immediately vulnerable to larger predators, including bigger sharks. Survival during those first few months is thought to be genuinely difficult, which is exactly why the right nursery habitat matters so much. By week 3 of tracking, her movement pattern changes again, and this time more dramatically. Instead of continuing north, she begins moving back and forth along a much smaller, tighter stretch of coastline. Researchers call this residency behavior, when a traveling animal stops migrating in one direction and starts staying in a single area. This particular stretch of coastline had already been flagged by earlier separate research as a likely nursery ground, based specifically on where juvenile great whites had previously been tagged, recaptured, or spotted in unusually high numbers. Her arrival here, at exactly this point in her pregnancy timeline, lined up almost perfectly with existing predictions. It wasn't proof of anything yet, but it wasn't a coincidence researchers were willing to simply ignore either.
This wasn't the first time researchers had identified a likely white shark nursery ground. Similar patterns of young, small sharks clustering in shallow coastal water have been documented in a handful of places worldwide. Parts of the southeastern United States coastline, certain bays along the coast of South Africa, stretches of Mexico's Pacific coast, where researchers have tagged unusually high numbers of very young individuals. In each case, the pattern looks similar. Small, recently born sharks spending their first months in warm, shallow, relatively predator-free water, far from the open ocean habitat their mothers spend most of their adult lives in. These nursery areas are rare, specific, and, for a species this wide-ranging, surprisingly small and localized, which is exactly why tracking a single pregnant female toward one in real time mattered so much to researchers watching this case. Scientists caution that nursery ground doesn't mean a single beach or bay. It usually describes a broader region where young sharks are repeatedly documented over multiple years. Confirming one usually takes years of overlapping data, not just a single pregnant female's tracked journey. Great white sharks are still considered vulnerable across much of their global range. Decades of overfishing, bycatch, and deliberate hunting drastically reduced populations in several regions throughout the 20th century. Recovery has been slow, partly because great whites reproduce so rarely compared to most other large predators. A single female may only give birth once every 2 to 3 years after that roughly 18-month pregnancy. With litters this small and pup survival rates in the wild still largely unknown, every successful nursery season matters enormously to a population's long-term recovery. That's part of why nursery ground research specifically has become such a priority in recent shark conservation work. It's not just about counting adult sharks anymore, it's about protecting the exact places the next generation actually survives its first vulnerable months. A pregnant female's 30-day journey isn't just a single animal story, it's a small piece of an entire population's future. In the final week of tracking, Her pings cluster tightly around one single stretch of shallow coastal water. Warmer, calmer, and noticeably closer to shore than anywhere she had spent meaningful time during the previous 3 weeks combined. This pattern matches a theory researchers have held for years about why nursery habitat gets chosen at all. That pregnant females deliberately seek out warm, sheltered water specifically because newborn pups, only a few feet long, need real refuge from larger predators, including, in some documented cases, other sharks of the very same species. Then, on day 30 of continuous tracking, her tag simply stopped transmitting new pings from that specific location. She may have simply moved beyond signal range, or she may have given birth exactly where the data suggested she would. Researchers still don't know for certain whether she actually gave birth during that final tracked week. Nobody was physically there to see it happen. Realistically, nobody may ever be. But 30 days of continuous tracking data did something no dead stranded specimen ever could. It showed in near real time the actual path a pregnant apex predator takes toward the place science believes she's going to give birth. It's not proof, but it's the closest thing marine science currently has to it. And that matters beyond pure curiosity. Because if researchers can reliably identify where nursery grounds actually are, those specific areas can be protected from coastal development, from heavy boat traffic, from exactly the kind of human activity that puts newborn, defenseless pups directly at risk. It's a reminder that some of the ocean's most basic questions, how one of its most famous predators actually gives birth, remain almost completely unanswered. Subscribe to the Abyss Report. We go back down next week. See you in the deep.